I'm Alan Fenn at MIT Lincoln Laboratory, and this is the course overview for adaptive antennas and phased arrays. Here's the course background and description. Adaptive antennas and phased arrays with rapidly scanned beams or multiple beams are often suggested for radar and communication systems. These systems can be ground-based, airborne, or spaceborne, and they typically must function in the presence of jamming and other sources of interference, including radar clutter. This course has 16 lectures and covers the topics of adaptive antennas and phased arrays. Both theory and experiments are covered in the lectures. Part 1, lectures 1 to 7, covers adaptive antennas. Part 2, lectures 8 to 16, covers phased arrays. Parts 1 and 2 can be studied independently in either order. Lectures 1 to 16 correspond to chapters 1 to 16 of the textbook, Adaptive Antennas and Phased Arrays for Radar and Communications. There are problem sets in the book that can be used to reinforce material covered in the course lectures. The intended audience is primarily for practicing engineers and students in electrical engineering. The prerequisite is an introductory course in electromagnetic theory. Here's a list of the lectures. Part 1 is Adaptive Antennas. Lecture 1 considers adaptive antennas and degrees of freedom. Lecture 2 considers array mutual coupling effects on adaptive radar clutter suppression. Lecture 3 studies the focused near-field technique for evaluating the far-field performance of adaptive phased arrays. Lecture 4 further studies the focused near-field adaptive phased array technique by using the method of moments to include mutual coupling effects. Lecture 5 further investigates the focused near-field testing technique in the case of an adaptive phased array radar system. Lecture 6 experimentally tests the focused near-field adaptive phased array technique. Lecture 7 investigates multiple beam antennas with high-resolution nulling, and this is done with experimental testing. In Part 2, Phased Array Antennas, Lecture 8 will give an introduction to phased arrays. Lecture 9 investigates monopole phased array antennas, design, analysis, and measurements. Lecture 10, monopole phased array characteristics are studied in the focused near-field region, which is pertinent to the lectures 3 through 6, which investigated the focused near-field nulling technique. Lecture 11 investigates displaced phase center antenna measurements using near-field scanning. Lecture 12 investigates a low side lobe phased array antenna using near-field scanning measurements. Lecture 13 investigates arrays of horizontally polarized omnidirectional elements. Lecture 14 investigates finite arrays of cross V-dipole elements. Lecture 15 investigates ultra-wideband dipole antenna arrays experimentally. Lecture 16 analyzes finite rectangular waveguide phased arrays. Here's a course content breakdown by topic. The 16 lectures are listed. The topics are listed in the left-hand column. Adaptive antenna theory, jammer nulling, radar clutter suppression, phased array theory, antenna measurements, array mutual coupling, far field characteristics, and near field characteristics. So if you want to study a particular topic, you can determine which lecture you want to study, or you can go through all the lectures, and these would be the topics covered in the lectures. The book Adaptive Antennas and Phased Arrays for Radar and Communications can be used to supplement the lectures. The book goes into a great deal of detail on each of the topics listed.